I'm Martin Yeomans. I'm a professor of experimental psychology at the University of Sussex, where I've been studying human eating, taste preferences, human ingestive behaviour for over 30 years now. My lab runs lots of different research, but particularly focused on how we can measure really well human eating and drinking, both in the lab and in the real world. And that's what I've been doing. I got interested in food research actually as an undergraduate. I've always been interested in what regulates our behaviour, and so much research is done on memory and attention, but actually so much of our day is spent thinking about food. And most of us wake up wondering what we're going to do for breakfast, at breakfast are wondering what we're going to do for lunch. And when we're eating, all sorts of thoughts come into our minds about, is this the right thing to eat? Are we eating too much, too little? And trying to understand the processes which go behind all that cognitive work and decision making is really important, particularly in a context where we've seen a worldwide epidemic increase in obesity. And that's why I love doing what I do. At the moment, in the laboratory, we can measure eating reasonably well, although the methods we've developed are clunky. They involve hiding balances in desktops so we can weigh what people are eating. And we can't translate that into the real world. There is one lab which has developed a way of measuring food off a scale, but you literally carry a scale with you, and that interferes with behaviour. The alternative way in the real world is to use diaries and get people to write what they eat, and unfortunately people aren't accurate. Famous work suggested that, for example, obese people eat less than normal weight people and actually expend less energy than normal weight people, and both those answers were flawed. It turns out the energy one, we had people sitting still in a room, and if you've got lots of insulation, which a larger body size has, then it does look like you're using less energy. Put them on an exercise bike, and that goes through the roof. And you calculate the energy they need to maintain that body size, it doesn't match to the energy they're reporting they're consuming. So they're under-reporting. I won't say lying, selective memory is probably the right answer. So if we're using self-report measures, we're never getting an accurate picture. And that's a huge problem. Well, the self-report limitations are, they rely on memory. So we now know that pretty much we clear our memory of what we eat within 48 hours. If I ask you what you had for breakfast today, you could tell me. If I ask you what you had for breakfast yesterday, you might be able to remember, but 2 days ago you won't. And so unless you've got an immediate record of what people are eating and how much they're eating, you're always working with inadequate data. So the laboratory type measures that we use, where we bring people into our lab and get them to eat, develop a method which was produced by the famous Harry Kiselev, a wonderful researcher from New York in the late 1980s, where he incorporated a balance into the desktop, and people ate from that balance, and you could record the weight as it disappeared. And the assumption was if the weight of food's gone from the balance, it must be going into their body. We developed that further into a more complex system at Sussex, we called the Sussex Ingestion Pattern Monitor, where we used that information live while they were eating to start giving instructions. So, for example, asking how full they were after every 50 grams they ate. And so you could measure very, very precise, approximate intake using a hidden balance system. It's massively clunky, but it was important enough that we were able to commercialize it and sell this. And so about 20 universities around the world were using that through the 2000s, a couple of food companies. So there was a demand for this at the research level. As a consumer answer, it's a non-starter. You're not going to be able to get people to take a balance with them and eat normally in a restaurant or anywhere else. So it's good for research. So one of the other really interesting developments in this area was at Wageningen University, where they developed what was called the Restaurant of the Future, where they had cameras everywhere. And so everyone who went in, they determined what food they'd chosen, and they analysed everything using remote camera sensors. It was incredibly laborious. They were very proud of it. I was intrigued to find when I went back to visit them 10 years later, they've abandoned the whole project. because the data analysis is just too complicated using that approach. And again, when people know they're being watched by cameras, again, that alters some of their behaviors, which is not good. So with our SIPM system, what we were doing was collecting data rather than giving instructions to people. So every 50 grams, we wanted to know how hungry, how full they felt, how much they were enjoying the food. There's a great mythology that, the hunger at the start of the meal predicts how much you'll eat. But that's not true. Actually, if you're eating something you don't enjoy much, your hunger goes down quickly. If you taste something and it's much nicer than you're expecting, you're actually hungrier part of the way through the meal than you were to start with. And this system captured that unique component of human appetite control, that appetite's not what you feel like when you start, it's how you feel once you're in the moment eating that food. In terms of companies that got interested in this, there were three groups. One is food companies who wanted to get a better handle on exactly how altering subtle things about a food, the packaging, the sensory quality, the nutrient content, altered consumers' experience, not just when they bought it, but as they consumed it. So they used it to track these behaviors to get a better handle on product development. And then you have people like the US Department of Health, who've got a big nutrition research center. They wanted to use this to track nutrient intake as they put people through weight loss programs to see whether training people to eat less using traditional dietary type methods could actually alter their real behavior in measured objectively. And then we have the pharmaceutical industry who are looking at drugs to try to treat obesity. And they employed this technology to test out whether some putative drugs, particularly those which perhaps modify our enjoyment of eating, did have the predicted effects when people were actually consuming foods in a laboratory situation. So I first found out about MTech when I was approached by someone I used to work with at the Innovation Centre at the University of Sussex, telling me about this company who developed smart glasses which they thought could measure food. And that piqued my interest because it has the potential to solve some of the problems I've come across with the methods we were already using. I then met MTech and was impressed by their enthusiasm for their product, but needed convincing behaviourally that this actually worked. And so fairly quickly we went from an introduction to actually measuring behaviour using these glasses. And the initial data we've got suggesting that the glasses, for example, can pick up over 90% of chewing events within an eating episode are astonishingly good relative to every other method I've ever looked at. And so I am fairly confident going forward that these are going to be revolutionary in terms of what we measure in human eating, although there's more work to do. In October 2023, I was approached by a colleague I used to work with when I was developing SIPM. That colleague works at the Innovation Centre at the University of Sussex, and he'd got a startup company called MTech, who claimed to have developed smart glasses that could measure eating. That piqued my interest, and I got in touch and started talking with them. MTech demonstrated the glasses and what they could potentially do. Because they're measuring muscle movements in the face, they're picking up the actual eating behaviours as they happen. And that is something that no one's been able to do reliably to date. So we then needed persuading that they really were measuring eating, because there are so many things our faces do. And we've run a couple of studies already which are developing really strong results. Particularly, we've been running a big project looking at chewing behaviours for specific foods, and these glasses pick up 90% of chewing events simply through muscle movements. At the moment, if we were to measure that in the lab normally, we would video code people, and it would take hours of laborious coding to produce the same results. And that would not give us, in the moment, information. We could only get that information afterwards. The nice thing about MTech glasses, to my mind, is they don't just measure eating. They're measuring lots of other activities at the same time. So, for example, movement, and we know that energy balance is a product of energy in matching up to energy expended. And so If you're trying to get people to lose weight, you're trying to adjust that energy balance equation, not simply alter their eating. You need them to move more and eat less, to use a much used UK phrase. This will help people potentially by providing that necessary feedback. They also, interestingly, pick up facial expressions associated with emotion. A lot of people who are overweight would score highly on measures of emotional eating, binge eating, eating in response to negative mood. And if we can track mood at the point at which it's experienced alongside eating, again, that gives us a unique way into potentially helping people with very specific eating problems. In the eating context, so far I've talked about obesity as the major problem which is facing the world, but we have also an increased incidence of eating disorders. For the most extreme eating disorder, anorexia, patients eat distressingly slowly. They can take 40 minutes to eat a quarter what a normal person would eat in 2 or 3 minutes. And people have grappled for years with ways of trying to help those patients relearn how to eat. And one approach founded by Per Söderström's group in Sweden was to use the balance type feedback system I talked about to provide real-time information back to the patient so they could learn to eat slightly faster and at the same time imagine feeling slightly less full. The glasses have the real potential to do that. And they're less clunky than carrying a huge balance around, but they can provide the same information at the same time as monitoring the emotional state of the anorexic during that process. So I could easily imagine a repurposing of these glasses into a very effective treatment for anorexia.